This is the 10th lecture. So today we are going to continue to solve the end of chapter 4 problems. And I believe last time we've solved problem 4-10. And the first problem that we are going to solve for today is problem 4-11. So using the linear interpolation, determine the value of P given A 6.5% over 10 periods. This vector value from the compound interest tables. And then compute this same value using the equation. And then we need to answer why these two values are different each other. Okay? So earlier this class, I mentioned the table values in Appendix C of our text do not include every possible interest rate or interest periods. So the interpolation technique can be used in such cases. Now let's compute the value of vector P given A 6.5% over 10 periods using the interpolation. Okay. So to minimize the errors, we need to find the two closest interest rates from the compound interest tables. So here we have two interest rates, 6% and 7%, which have 7.36 and 7.024 respectively. So let me make a table. I%. Okay, this is the problem number 4-11. And I is going to be 6% and 7%. And the corresponding vector values 7.360 and 7.024. Okay. So now we can sketch simple diagram. Let's say so the horizontal axis represents the interest rate. The vertical axis represents these vector values. Okay. So we have 6% and 7%. And the targeted vector values are at 6.5%, right? And these vector values as 7% would be, let's say, 7.024 somewhere here. And 7.36 at 6%. So you need to connect these 2 points. Okay. So we have one big triangle like this. Okay. And let's say somewhere between these two values we have x, okay? That corresponds to 6.5%, okay? So we have this small triangle. Okay, so this small triangle is called triangle A. And this large triangle is called triangle B. Okay? Then our linear interpolation is rely on these two triangles. Okay? So basically the height of triangle A versus the base of triangle A equals the height of triangle B versus base of triangle B. Okay? So how do you get the height of triangle A, which is this much? That's going to be 7.36 minus x, right? 7.36 minus x. And the base of triangle A is 6.5% minus 6%, right? 6.5 minus 6%. Likewise, the height of triangle B can be obtained by 7.36 minus 7.024. So 7.36 minus 7.024 versus the base of triangle B, which is 7% minus 6%. So 7 minus 6. Okay? So here, 7.36 minus A minus x is equal to, this is 0.5, right? 0.5 times, what is this value? That's going to be 0.336, right? And divide by 1. 7 minus 6 is 1. So just this, right? So x is negative 0.5 times 0.336 plus 7.36, right? What is this value? It's going to be 7.192. Okay? And the problem description also asks us to compute the same value using the formula. So what formula do we need? P given A 6.5% over 10 periods. It's going to be 1 plus I to the power n minus 1 over I times 1 plus I to the power n, right? I is, of course, 0.065 and n is equal to 10, right? So this is going to be 1 plus 0.065 to the power n power 10 minus 1 over 0.065, 1 plus 0.065 to the power 10. So from my previous calculation, this is going to be 7.189. Okay. So if you compare these two values, 7.192 from the linear interpolation, 7.189, which is from the equation formula. And you notice that there is a small differences between these two values. Why do you think these two values are different? Because the compound interest factor is nonlinear. Because the compound interest factor is nonlinear. Okay? So the linear interpolation will not produce an exact same value, exact solution. Okay? That's the reason why we have two different values from two different approaches. Okay? Okay, then let's solve the problem number 4-28. So a young engineer wishes to become a millionaire. By the time he is 60 years old, he believes that by careful investment, he can obtain a 15% rate of return. He plans to add a uniform sum of money to his investment program each year, beginning on his 20th birthday and continuing through his 59th birthday. How much money must the engineer set aside in this project each year? Okay. So again, let's draw the cash flow diagram first. So we are working on problem number 4-28. Okay. So starting from his 20th birthday, so let's say 20th birthday, he start investment. Okay. Up until his 59th birthday, right? So he wants to know the annual deposit amount, starting from his 20th birthday up until 59th birthday. Okay? And then you want to be a millionaire. $1 million on his 60th birthday. Is that right? So the diagram indicates that the problem is not in the standard form of the uniform series. So what I'm going to do is I'm going to set future sum, let's say f sub 59, at the end of 59th period. Okay? Then here, f sub 59 can be obtained by $1 million then P given F 15% and over one period, right? And what is this value? %, P given F. So you need to look at page 615. Over one period would be 0.8696. So this value is 0.8696. So how much is that? It's going to be $869,600. Okay. So F sub 59 is $869,600, and this amount of money can be converted to an equivalent uniform series of A. Is that right? So here A is going to be this amount of money, 869,600 times A given F, right? And same interest rate of 15% over how many periods? The number of yearly investments would be 59 here minus 20, right? And plus 1, which is 40, right? So we're going to use the n equals 40. So how much is that? Again, 15% A given F over 40 periods, which is 0.00056. This is the 0.00056. Okay? And this value is going to be $486.98. Okay? So in order to be a millionaire, on his 60th birthday, he need to deposit $486.98, okay, every year. And just to let you know, this result is very sensitive to the sinking fund factor. The actual sinking fund factor value is 0.00056208. Okay? So if we use this exact vector, more accurate vector, then he must set aside $488.78 each year. Okay, so there is a difference, slight difference between these two values. Okay, then next problem that we are going to solve is problem number 113, okay, which is about the case where the compounding and payment periods are different from each other. Okay, so a contractor wishes to set up a special fund by making uniform semi-annual and period deposits for 20 years. The fund is to provide $10,000 at the end of each of the last 5 years of the 20-year period. If the interest is 8% compounded semi-annually, what is the required semi-annual deposit? So again, let's draw the cash flow diagram first. So we are working on problem number 4-113. So we set up a fund by making uniform semi-annual and period deposits for 20 years. So there are 40 times of deposits, right? Because there are 40 semi-annual periods within 20 years. So for the next 40 periods, right? So one more. Okay. So let's say this is the 40th period. Okay. So 1, 2, 3, and 39, 38, 37, 36, and so on. Okay. And the fund is for providing $10,000 at the end of each of the last 5 years. So here's the tricky part. So basically we want to know the value of A, right? When you consider the value of A, the unit is semi-annual period. But when you consider the $10,000 that the fund is for providing the $10,000, right? So when you consider this amount, $10,000, the unit is years, not the semi-annual periods. So at the end of each of the last 5 years of the 20-year period, so 1, 2, 3, 4, and 5. This amount is the same as $10,000. Is that right? And what is the interest rate that you are going to use? Is that 8%? No, it's going to be 4%, right? Semi-annually. Because there are 2 semi-annual periods in a year, so 8% divided by 2 becomes 4%, right? So this is the interest rate that we are going to use. So this positive cash flow amount should be the same as the negative cash flow amount. Is that right? So here, let's say at the end of 40th period, we have a future sum F. Okay? Then this future sum F would be same as this positive cash flow, which is 10,000 times F given P, 4% over how much period? 8 period. Okay? Those are the tricky part, right? It's not the 4 period. It's going to be 8 periods. Plus 10,000 times F given P, 4% over 6 periods. So if you keep going, it's going to be 10,000 times F given P, 4%. Now it's going to be 4 periods. 10,000 F given P, 4% over 2 periods. And the last one, you just need to add up. Okay? It's going to be F. So if you take out 10,000, then what is this factor value? So we are looking for 4% interest rate. We need to look at page number 606. F given P is provided in the first column. Over 8 period is 1.369. Over 6 period, 1.265. Over 4 periods, 1.170. Over 2 periods is 1.082. And don't forget the last term. It's going to be 1, right? So how much is that? So this is the $58,850. Okay. So what he did is we got the value of F, future sum F, which is equivalent to these 5 $10,000 withdrawals, right? Now, this future sum F can be converted to an equivalent uniform series of 40 deposits. Is that correct? So, the required series of 40 deposits would be A equals F. F is same as this, right? Times A given F, same interest rate, the 4% over how many periods? 40 periods, right? So 40, which is 58,850 times A given F, 4% over 40 periods. So what is the value? That is 0.0105. 0.0105. So what is this value? That is $618. So this is the required series of 40 deposits. Okay. Okay, so what is that value? Okay, the problem what he just solved is problem 113. Now let's solve problem 4-32. Okay, so here, if the interest rate is 12%, for what value of B is the present value of 0? Okay. So here, the present value of the receipts and the expenditures are 0 at time 0, right? This means that all these positive cash flow amounts are equal to the all of this negative cash flow amount at time t equals 0. Okay. So let's say the receipt, okay, this is the problem number 4-32. The receipt at time t equals 0. Or it's better to use the time t equals 1 because it's redundant. Okay, so let's get the receipt value at time t equals 0, time t equals 1. That's going to be the B itself plus 800 P given A, right? And 12% over how many periods? 3 periods. So, of course, if you want to use the reset at time t equals 0, then that's going to be P given F 12% over 1 period, and then 800 P given A 12% over 3, and then you need to convert this future value to the equivalent present value. So it's going to be P given F 12% over 1 period, right? So obviously this formula is a lot easier than this, right? So we are going to use reset at time period t equals 1 instead of 0. So how much is that? 12% P given A over 3 periods. That is 2.402. This is 2.402. Okay. And what about this negative cash flow? The expenditures at time t equals 1 again. That's going to be B, those two B's, P given A 12% over 2 periods, right? Plus this 1.5B. This future sum can be converted to the equivalent present sum at time t equals 1. So P given F 12% over how many periods? 4 minus 1 is 3, right? Over 3 periods. And we need to get these two factor values, 12% P given A over 2 periods, there's 1.690. P given F over 3 periods, 0.7118. 0.7118. So what is this? That's going to be 2.758 B. Okay? Oh, and I forgot to provide you the reset. Time t equals 1. That's going to be B plus this value is 1921.6. So I said earlier, all these positive cash flow amount are equal to all of this negative cash flow amount at time period t equals 1. So what you need is that this receipt value is equal to this expenditures at time period t equals 1. Okay, so B plus 1921.6 equals 2.758 times B. So what is the value of B? B is 1921.6 divided by 2.758 minus 1, right? How much is that? Okay, that's going to be $1,093.06. Okay. Okay. Okay, then next problem that you are going to solve is problem, what about problem 4-35? So Jerry bought a house for $500,000 and made a $100,000 down payment. He obtained a 30-year loan for the remaining amount. Payments were made monthly. The nominal annual interest rate was 9%. After 10 years, which means after 120 payments, he decided to pay the remaining balance on the loan. And we have two questions. The first question is what was his monthly loan payment? The second question is what must he have paid in addition to his regular 120th payment to pay the remaining balance of his loan. Okay, so as usual, let's draw the cash flow diagram first. So problem number 4-35. So in order to answer for the first question, okay. We draw the cash flow diagram like this. $360, $359, $358, and then 1, 2, 3, 0, right? Like this. So what is the first question? First question is asking his monthly loan payment, right? So which is about A. And what is the present sum? The house price is 500K, and he made 100K down payment. So for the remaining amount, which is 400K, 500K minus 100K would be 400K. He had a 30-year loan, right? So he has 400K. And the payments were made monthly, right? The payments were made monthly. And the nominal annual interest rate is 9%. So this tells us that the interest rate is 9% compounded monthly, right? This means that the bank charges 0.75% monthly. Okay? So how do you get this value? 9% divided by 12, because there are 12 months in a year, right? So here we have A equals 400,000 from here, right? Times A given P and 0.75% over how many periods? Over 360 periods. So can you get this value from our table? Okay, we are looking for 0.75, so 3/4%. So you need to look at our text page 597. Okay, so they are providing this vector value. Okay, so A given P over 360 periods, that is 0.00805. Okay. So what is the value of A? That's going to be $3,220. Okay? So because this 400K should be converted to an equivalent uniform series of A over 360 periods. That's why we use this formula, right? And finally, we got this uniform series of $3,220 over the next 360 periods. So this is the answer for A, right? Okay, then how do you answer question B? What must he have paid in addition to his regular 120th payment to pay the remaining balance of his loan? Okay, so in the problem description, it says after 10 years, which is after 120 payments, he decided to pay the remaining balance on the loan. So, in order to answer this question B, let's redraw the cash flow diagram. So here, 120th payment, 120th month, okay? And here we have 121st month, here 122nd month, and so on, up to 360th month. Okay? So here we have this annual, the monthly loan payment of, how much is that? From question A, it is $3,220, right? And if we set, let's say, P prime here, after the 120th month, okay? After 120th payment, okay? Okay. So we said P prime is like this. Then these are the remaining balance of the loan after 120 payments. Is that correct? So we need to convert this uniform series of how many payments is that? And there are 240 payments, right? Because there are 240 months. So we need to convert this uniform series of 240 payments to an equivalent single payment at the end of 120th month. Is that correct? So let's compute P prime at the end of 120th month. There is going to be A, which is $3,220 times P given A, right? And same interest rate, 0.75% over 240 months. Okay, and the page number 597 provides this factor value, P given A over 240 periods. That is 111.145. 111.145. Okay? So, what is this value? Okay, so this is going to be $340 $57,887. Okay. So this is the answer for question B. Okay. Next problem. Okay, let's solve maybe how about okay, let's solve problem 4-36. This is a little bit longer. Or let me solve this problem next time, but this time let's solve 4-39 first, okay? Because this would be a little bit easier than problem 4-36. But I will going to go back. Come back to 4-36 next time. Okay, so let's consider problem 4-39. A company buys a machine for $12,000, which it agrees to pay for in 5 equal annual payments, beginning 1 year after the date of purchase, at an annual interest rate of 4%. Immediately after the second payment, the terms of the agreement are changed to allow the balance due to be paid off in a single payment the next year. What is the final single payment? So let's draw the cash flow diagram first. This problem number 4-39. So you paid $12,000 and agrees to pay for in 5 equal annual payments. So 1, 2, 3, 4, and 5. Let's say that is equal to A. Okay? And this equal payments begins 1 year after the date of purchase. So the cash flow diagram is like this. And what is the interest rate? Is 4% of interest rate, right? Okay, then what uniform annual payments he has to make? It's going to be A equals $12,000 times A given P, right? And 4% over 5 periods. So from our text, page number 606, A given P over 5 periods is 0.2246. times 12,000. So how much is that? It's going to be it's $2,695.20. Okay? And in the problem description, immediately after the second payment, you are allowed and want to pay off the balance due in a single payment in the next year. Then what is the final single payment? The final single payment is the present worth of the 3 unpaid payment, right? Is that the final payment would be the present worth of the unpaid payment, right? This is the final payment. So I said final payment is the present worth of the 3 unpaid payments, right? So how'd you get this value? That's going to be this amount. How much is that? $2,695.20 plus the same amount, $2,695.20 times the P given A, 4% over 2 periods, right? You need to convert this uniform series to the equivalent present worth at the period 3, right? So that's why you need to multiply by this factor. Then what is this? How much is that? 4%. So you need to look at our text page number 606. P given A over 2 periods is 1.886. This is 1.886. Okay? So how much is that? Okay, this is the $7,778.35. Okay. So this is the final single payments after the second payment. Okay. Okay. So I'm going to stop here for today, and next time we are going to continue to solve the end of chapter 4 problems. Okay. Thank you very much. See you next time. Bye.